Okay, guys, you there? So we have, I want to prove the summation laws of delta epsilon. Okay, so how do I know that the limit of the sum is the sum of the limits? So here we go. We're assuming, and let's play together. We're assuming that this limit exists and equals L, and that the limit for G exists and equals M. And I want to show that limit of the sum is the sum of the limits using delta epsilon. So here I'm not sure, I just went over inequalities because people somehow don't know inequalities pretty well. I'm hoping that you read it, or if we need to, we'll go back to them later on. Okay, so what is in this problem? So we know that limit as x goes to a is L, which means there exists a control function delta f of epsilon. You understand what this function is doing? I don't know what f is, but because I'm saying that limit exists, that means by definition that I have a control function, which means if I use f as my canon, then I can aim the current to converge around L, go into any pipe of radius epsilon by closing the valve appropriately, and that will create delta of f. Yes? Good? So we will have, whenever, what does it mean? It means whenever x minus a is less than delta f, then f of x minus L will be less than epsilon, which means the particles enter the pipe of radius epsilon around L. Good? Now, similarly, there is a function delta g of epsilon that will allow me to make the current of G converge around the point M. Yes? So I can make the water current converge to M. I can throw it by delta G. Good? Now, I want to make f of x plus g of x minus L plus M. I want to make this less than epsilon. Yes? I want to make it less than epsilon, which by triangle inequality, I can just group f with L plus g with M. And triangle inequality, this summation, absolute value of a sum, is less than or equal to the sum of the absolute values. I'm hoping you know this rule. I don't kind of want to right away go over it. But if you do want to go over it, we can do that. It's just if I have absolute value of a number plus another number, it's always less than or equal to the absolute value of each number separately added up. Okay? Now the question is, how can I make this sum less than epsilon? And do you want to, before I say it, can you take a guess? I want to make this plus that less than epsilon. So what do I do here? What do I do here? So I want to put here less than epsilon. All I have is delta G and delta F. I need to use those functions to command, right? So I program into the function what to do.
Can I see delta F?
Sorry?
Can I see delta F?
Well, there's nothing about it. Delta f of epsilon is just hypothetically existing because limit of f exists. You understand? I know nothing about this function. I just know it's given to me. It's like a black box in programming, right? It will. So delta f is a function that controls the stream coming from f. So this means the stream from f plus g is less than or equal to the stream from f plus the stream from g. Okay. And I want both streams to go to add up to no more than epsilon. So what do I do with the left part? What do I do with the right part? How do I accomplish that? Obviously, my only ability is to change delta. So I have to somehow combine delta G and delta F. So I will ask in my extra credit questions, I will ask this type of question.
Wouldn't you combine the two?
Yes, but how do you combine the two precisely? The question is how to combine the two.
Absolute value, I'm gonna say negative L minus M, and then you have Plus x in parentheses f plus g.
Well, f plus g, you see, I know nothing about those functions. You have to be really careful, okay? Very, very careful what to do with, this is just delta of g, which means just what is delta of g means if this is telling me how close must I make my valve so that the current from this pipe will be gushing near M. So delta G tells me how to make the current gushing from the x-axis. This is the radius of the horizontal pipe, of the input pipe. And this is the radius of the target pipe, right? So with this function, I can control this expression, okay? And with the similar function for F, I can control F, okay? So let me show you how to do that. And the next you might try to imagine yourself, okay? So this is the limit laws for addition, you understand? I prove limit law of addition. I prove that I can control simultaneously both F and G so that the water current will be narrow around L plus M, okay? So here is how I will do that, okay? So if I will select delta less than or equal to delta F of epsilon over 2, that will make the water from F be focused around L within a pipe of radius epsilon over 2. And if I select delta smaller than delta G of epsilon over 2, that will make the G water gush towards M less than epsilon over 2. So the delta, combined delta for both of them, delta for F plus G to control F plus G can be taken to be the minimum of delta F or epsilon over 2 and delta G epsilon over 2. Do you understand? Because if my delta is smaller than both of them, then it ensures that in absolute value for F, it's less than epsilon over 2 plus the absolute value for G is less than epsilon over 2. So epsilon over 2 plus epsilon over 2 is less than epsilon. You understand? So I ensure that the current in F will go into a pipe half the radius around L, and G will go to a pipe half the radius into M. And that means that F plus G will go near L plus M into a pipe of radius epsilon. You understand how I managed to control it?
Yeah.
That's the idea.
Does it matter? Like if C it's like epsilon over 2, like what if you put like epsilon over 3, like would that still be correct?
It would work. And in fact, once you realize that epsilon is arbitrary, you don't have to worry. If it's a constant times epsilon, that means just you can correct for it forwards. For example, if I can make it go into a pipe of radius 7 times epsilon, then all I do is just whenever you give me epsilon, I will take epsilon over 7 as my pipe. You understand? So I can always correct for it. You understand what I'm saying, right? So if you prove that you can get into a pipe, the current into a pipe of 7 times the radius of the pipe you requested, for any pipe, you understand? Then whenever what I do is I just correct. I have a corrective lens before. So you tell me feed it into a pipe of radius 5. I will feed it. I will in my formula. I will put 5 over 7, and that will feed it into your pipe. You understand? So I can always correct for it. So later on, you stop being so annoyingly rigid about epsilon. There's nothing special about it. Or you're just talking about gathering the current into an arbitrarily thin pipe. And if epsilon is arbitrarily thin, then 5 times epsilon or any number, fixed number times epsilon is arbitrarily thin. And that's what I explain it in analysis more precisely. You understand? So I hope you guys figure out. You understand how I made it work. It's very simple logic. You see, if I understood triangle inequality, look at it. F plus G minus L plus M, I group F with L because I can control this and make it small, and G with M. And that is a number plus a number. Absolute value of a sum of two numbers is less than or equal to absolute value of one plus the absolute value of the other. And above there, I try to explain why that's the case, because I think many students have not taken inequalities for some reason, right? So this part can be made small and this part can be made small. Now, what do I want this plus that part to be smaller than epsilon? So how can I do that? I can, I need to select, so I'm gonna close my delta. I know if I close it to within epsilon over 2, so in other words, delta F within epsilon over 2, then this part is less than epsilon over 2. And if I close it to delta G of epsilon over 2, then this part is smaller than epsilon over 2. I need them simultaneously to be smaller than epsilon over 2. And what do? I just take the minimum. So I basically close the lid. As soon as I see one function is already working, wonderful, then I continue closing the lid until the other will work. So that's why I take the minimum. Make sense?
Yeah.
And then you have the limit law for products. I also show how to do that. It's more complicated. I don't want to go over it. I do it in general. I actually even bothered to my grievance to actually do it for epsilon. I could have done it for constant times epsilon, but I did it so that you are not blaming. Here is the type of question that I might ask on an exam. Okay, so to make sure that people understand it or not. Well, maybe they will cheat. Maybe they will still have the right answer. But limit as x goes to 5 of f of x equals to 10. So this is given, suppose, right? So use a delta epsilon argument to, let's see if you can do it, okay? So this, I don't know what is f, you understand? I have no idea. But somehow I know that as x goes to 5, f of x will go to 10. Show me that 2 times f will be 20 using delta epsilon. Obviously it's 20. Obviously I can use limit laws, you know. I mean, this is just a test. Delta epsilon for us are only, you look at it. I prove here product rule and I proved additional. I can prove all the others, of course, right? So delta epsilon will make those limit laws non-arbitrary so that you can rely on them safely. It has other, of course, other purposes. Today, actually, I was teaching a German guy for a probability in the morning. So you see, I cannot. I have to torture somebody. I have advisor genes. That's my joke. Advising, it's my joke for something else.
All right, Professor, I gotta go.
That's it, Christian. You're leaving me.
Yeah, I'm sorry, Professor.
Not too bad. But think about this question. Nice to see you. Have a good one.
You too.
SM Ahmad, are you here by any chance? And who else is here? Brian, are you here? To think more logically, I don't know. You see, it's very difficult to figure out how to think logically, right?
Sorry,
It's just
did I cut you off?
no, Christian. You said goodbye. It was very nice of you,
Oh, okay,
right?
okay.
Don't worry about it. Very nice to speak with you. Don't worry when you have to leave. You see, no trouble.
Okay, thank you.
You stay anyhow above class time. Okay, guys. So you understand why am I able to answer this question? Or very simply because I actually picture what I'm doing. You understand? So some people, when they cannot answer it, they are looking at letters and the letters don't mean anything to them. It's not because I figured something much more complicated. It's just the letters mean something to me. I can take letters, translate to meaning, and translate meaning to letters. At least in some instances, obviously, right? It's if I could do it absolutely, that's a different story. Okay. the example I came up with, right? That's why mathematics that's why mathematics isn't boring to me, because, well, I could imagine such examples myself. I mean, you look at the description and you can imagine what the description means. When you do that, when you try to get to the meaning, you are thinking better. Well, visual, maybe I'm also visual, guys, right? So Ahad, SM Ahad, you say you're a visual learner. What do you mean by visual learner? So perhaps we can do what helps you there. What is visual? You see, there is this thing that this thing. So I see a phone, right? I see it. I'm a visual learner, but when the phone is not around, I remember some parts about it. So I see in the inner with my inner eye, right, the object. So here it's a similar idea. I look at the description and I try to see with the inner eye. So I try to imagine what the description refers to. And my analogy was, we have a faucet and somebody is closing this faucet, right? So we have this program, right? So you have this faucet and it's gushing out water, and there is a program that will make this cannon. It will make the near 5. It will make the current converge to 10. In other words, the current can be made narrow. So that's how I imagine it. You see, Ahad? I imagine that the current can be narrowed using some operation. I can just control it, right? I cannot control it directly. I cannot touch the faucet, but I can put some inputs into a machine, and the machine will narrow the current. So I want to know how to construct, using the machine that will narrow this current, how to modify the algorithm to narrow this modified machine current. That's how I think of it.
Yeah, I kind of get it.
Mm-hmm.
Like it's kind of like the same problem that you were just talking about before, where you kind of make the hose smaller, but you're still hitting within like the other pipe.
Yeah, we have a machine working for we have a control to narrow the beam around 10. I need for the new modified function, I need to modify the control. You understand? So I'm like reprogramming it. I'm working with what's already available, like a corrective lens. You see, so that's
Okay.
what we're doing. We already have something. We need a corrective lens, or we need to modify so that it will narrow around 20.
Maybe what I have down so far is like I have like absolute value f of x minus 10 is less than epsilon.
Okay.
And whenever x minus 5 absolute value is less than delta epsilon f delta f epsilon, which is from like the previous.
Right.
Yeah, which is from like the previous you were just talking about.
Yes,
But I don't know where to go from there.
Okay, what do you do from there? I can answer it, of course. You see, I mean, it's hard for me to say anything more without answering it. Right, so what are you trying to do? You imagine that 2 times f minus 20 in absolute value, you made it less than epsilon. What did you do?
So after that, you do the inequality, no? Like
You understand? So you can always imagine that you did something and you were able to get the current into the pipe, and then you ask yourself, what is it that you did? Make sense? It's the same idea as before. It's just a little more abstract. Here you have to rely with a black. You have a black box, because I know nothing about f. I have a black box for it, right? A black box controls f, right?
Okay.
So I can modify the black box, but not. I cannot construct one from scratch. That's the problem, right? So you see that's a better question, because if a person answers it, then they really understand delta epsilon. If they did the algebra before, they can, and I've seen it before, people just follow the algebra, but they don't understand it, because they realize what they have to do to solve this particular problem, but they don't understand why the solution works or what is it doing.
Yeah, that's where I am.
No, it's okay. It's maybe farther than where I was when I began learning it, but okay. Well, okay. Thank you, Ahmed, for staying with me, and good luck with everything. And again, what I do, the only reason I understand anything here is that how I built it up is that I always try to imagine what is the gist, the tachlis, if you say that. I'm not sure if you use that word. The essence of something, right? So just you have complicated words, you have complicated descriptions, and very often those descriptions are meaningless. What's the actual thing that you're trying to describe? Is there any depth to that? All right, anyhow. And you, Brian, are you here? Or forgot to log out? Brian. Okay, I guess Brian isn't here.
Yeah. I mean, so from what I see, it's like, so the second equation is basically 2 times bigger than the first one, right? The first limit, I mean.
Okay.
And so how I would think about it is like, since like, if I applied the same logic to the second limit, I would probably get like f of x, 2f of x minus 20 is less than epsilon.
Okay.
That's like the same logic, right?
Yeah.
But like I still don't understand the question. Like, how do I show that like this equals that?
Well, you want
like,
yeah, I mean, it's in my notes are there. I can show you, right? And then you will laugh. Maybe it will help you, or maybe not. Okay, so I'm showing.
Okay.
No worries. You can have plenty. I can always come up with questions. I already imagine people saying it's not fair. Right? It is very fair. So here is, I have the delta f, right? You agree? And then I have this.
Yeah.
And then what can I do? I just I can factor out the 2 and divide. So that if 2x times f of fx minus 20 is less than epsilon, that means f of x minus 10 is less than epsilon over 2. So just plug in epsilon over 2 into the delta f. Make sense?
Okay. So I should have just taken the second one and just factored out the 2, and then I would have gotten the answer.
Yes, factor out the c. You begin with this over 2 divide. F of x minus 10 is less than epsilon over 2, which how can I make f of, so basically this is saying this will be true as long as this is less than epsilon over 2. Do you agree? If this is less than epsilon over 2, then this equation is true. If this equation is true, then this one is, right? So I can control that, right? So all I have to do is I use the delta of epsilon, it will be delta of f at epsilon over 2, and I'm done.
Okay, that was really simple.
But the answer makes sense.
It does.
Perfect, right? There will be another comprehension check here, right? You see here with more complicated. The type I have. Limit as x goes to 3 of f is 7, and of g at 7 is, so a 3 of f at 7 and a g of 7 is 1. So then I want you to show that limit as x goes to 3 of g composed with f of x is equal to 1. So that you can think maybe another time, right? Take a time and think about it and see if you can answer it. You understand? It's the same game, but maybe slightly more complex than the previous question.
Yeah,
well, I will try to come up with. I actually have a feeling that many people will just either try to. Of course, those questions you cannot immediately type and search, but possibly you can ask somewhere on the forum and or pay somebody and they'll do it. We'll see. I will try to ask a question, maybe like this one on the extra, right? We'll see.
Okay.
Good?
I'll definitely try to solve this then, yeah.
Wonderful. All right, have a good one. Or you want to talk about something else?
I actually have to eat dinner now.
Okay. So I am stopped.